Assalamu alaikum. I am Habib Shah, and this is my 10th lecture and second online lecture. And the chapter which we are studying nowadays is probability, and the topic discussion today will be uh, definition of probability, subjective approach, objective approach, and laws of probability, which will contain law of complementation and addition law. The first is actually the definition of probability, and um, we have already studied this subjective approach in the first lecture, but today I'll give some overview. As its name suggests, the subjective probability is a measure of the strength of person's belief regarding the occurrence of an event. It is purely based on subjectivity of a person. Whatever evidences are available to him, he will make his statement, he will write his record, his probability based on those evidences. And it has a disadvantage that two or more persons having the same evidences may arrive at different probabilities or beliefs. Now we will come to the objective approach. Objective approach, objective probability is where we can quantify the probabilities, where we can assign numerical values to the event. But the main advantage of objective approach is that every person will arrive at the same results. The classical or prior definition of probability is basically if a random experiment that has n mutually exclusive and equally likely outcomes, and out of those n outcomes we are interested in m outcomes, and those m outcomes will be our favorable outcome, and that will make the event for that particular or set for their event set for that particular question. Then the probability of this event denoted by PA is defined as a ratio m by. Now we can write as like this: probability, number of favorable outcomes divided by total number of possible outcomes. These favorable outcomes basically are those in which you are interested, for which you have to find the probability. So that will make our event, this numerator one, right? And this total number of outcomes basically are your is your sample space. Is what is your sample space? This one. Okay, and you can see we have written what, m by n, and over here number of elements in set A and number of elements in set S. Example is that if a card is drawn from a deck of 52 playing cards, find the probability that card is a red card, or second one, the card is a 10. There are 52 playing cards. There are 52 cards which are similar in nature, and out of those we have, we have already, if a card is drawn from a deck of 52 playing cards, if we have to draw only one card from this deck, so out of these 52, we have to select only one, and we will use what? We will use combinations, because they are of similar nature. This is how you will find, and the result will be this 52. Let A be an event that the card selected is a red. Now there are 26 red cards, and we have to select one. So the number of elements in set A will be 26. You can see this, it will be 26. So probability of A is equal to n by A or n over S. So number of elements in set A is 26 and number of elements in set S is 52. So the probability is 1 by 2. and now B be the event that the card selected is 10. Now there are 10 cards and we have to select only one, right? There are 4. Number of elements in set B, how many will be there? There will be 4 elements. So the probability is given by 1 by 13. Dear students, a fair coin is tossed 3 times. What is the probability that at least one head appears? So the solution is, the sample space for this experiment is 8. Right? You can see number of elements in set S is 8. And what is the event? The event is at least one head. At least one head. So let A denote the event that at least one head appears. Then we have got these 7 elements in set S A, and at least one head appear means that it can contain 1, 2 or 3 heads. So number of elements in A is 7, hence probability of A is 7 by 8. Example 3. 4 items are taken at random from a box of 12 items and inspected. The box is rejected if more than one item is found to be faulty, defective item. Faulty means defective item. If there are 3 faulty items in a box, find the probability that the box is accepted. So, solution. The sample space contains, how many items are there? 12 items. And how many? We have to select 4 items are taken. 4 items are taken at random from a box. Right? So we have to select 4 items out of 12, and the number of possible items units in set S is 495. Let A denotes that the number of faulty items chosen is less than 1, and this less than 1 means what? It can be 0 or 1. Is less than or equal to 1. Why? Because it says that if the box is rejected if more than one item is faulty. So more than one item faulty means less than or equal to 1. So it's 0 or 1. Number of elements in this is, this is how we will calculate. You see, after faulty items, 0. How many faulty items, total faulty items are there? There are 3 faulty items. So you see this 3C1, 3C0, sorry, 3C0. How many items are good ones? There are 9 items, and out of those 9 we have to select the 4 items, because we haven't selected even a single item out of those 3, because this is 0 is my selection. So we have to select all 4 from the good items, non-defective items. Plus, if one item is faulty, if I select one item, so this will be the pair of combinations. So the total number of elements will be 378. Probability is 0.6. Then we have just put the values in number of elements at A and number of elements in set S. Axiomatic definition of probability. We have got basically 3 axioms, and the first one, you can see let S be the sample space with sample points E1 up to En. Each sample point we assign a real number denoted by PE, probability of any event E, and that must satisfy the following basic rules. Axiom number 1: for any event EI, PEI should be less than or equal to 0 and should be greater than or equal to 0 and should be less than or equal to 1. Example number 2, probability of S is equal to 1, which is a sure event. And example number 3 is, if A and B are mutually exclusive events or subsets of S, then probability of A union B is equal to probability of A plus probability of B. These are the three basic examples which the probability of any event has to satisfy. Basically, the laws of probability. Theorem 1, if phi is the impossible event, and this impossible event is actually what is also called as null event. Null event. So proof is what? How can we the impossible event phi and the sure event S are mutually exclusive and exhaustive events. Then we can write what was the definition of exhaustive events? That if two events are mutually exclusive, the union of both events gives us a sample space, then we call it as exhaustive events. So if we take the union of this phi and S, that will give us what? Sample space. Dear students, remember this, that if this set and this S, these two are equal, it means that their probabilities must be also equal. And since these two events are what? These two events are mutually exclusive, so according to the third axiom, we can write probability of S plus probability of phi is equal to, I've written over here using third axiom, S. And this relation gives us that probability of phi is equal to 0. It's not S, it is mistakenly written as S. This is phi. This is actually not S, this is phi. The next is the law of complementation. If A bar is the complement of event A relative to the sample space S, then probability of A complement is equal to 1 minus probability of A. And what the proof is? We know that A and A complement are mutually exclusive and exhaustive events. Therefore, it's the same one. We can write A union A complement is equal to probability S, and if these two events are equal, if these two sets are same, then we can write that the probability of A union A complement is equal to probability of S, which gives us probability of A plus probability of A complement is equal to 1. I've written axiom number, this is the second axiom and this is the third axiom. So this gives us this one result. Example is, it's a very nice example. A coin is tossed 6 times in succession. What is the probability that at least one head occurs? Solution is since the coin is tossed 6 times, therefore the sample space S for this experiment consists of 64 sample points, as each coin can result in 2 outcomes. So NS is equal to 64, and let A be an event that at least one head appears, then the event A consists many points, and the probability of this event cannot be easily calculated. On the other hand, we know that A complement, which is the event that no head appears, contains only one element, and that is this one. So the probability of A complement is 1 over 64. So this is the probability of A complement, but what we require is probability of A, that at least one head appears. So hence, by law of complementation, probability of A complement is equal to 1 minus probability of A, or probability of A is equal to 1 minus probability of A complement. So this is our result, this one, 63 by 64. Now, addition law of probability. This is the Venn diagram, and you can see that this red area, which is A intersection B complement, and this yellow area is A intersection B, and this area is A complement intersection B. So this is the Venn diagram for what is the statement? The statement says if A and B are two events defined in a sample space S, then probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Proof. A union B can be written as the union of two mutually exclusive events. You can see those two events, and those events are A, event A, this full event A. We can write A union B as two mutually exclusive events, event A, and A complement only this portion of this event. That is, it can be written as this one, right? So if these two events are, if this equation is true, then their probabilities can also be equal. If these two are equal, then the probabilities are also equal. And since these two events, A and this one, are mutually exclusive, we can also use the third axiom and write it like this. This is my equation 1. Also, event B, just event B, we will now consider this full event B, can be written as the union of two mutually exclusive events. Which two events? First one, this A complement intersection B and A intersection B, and these two are mutually exclusive events, and collectively they will make what? If they combine together, they will make event B. We can write it like this, right? And since these two are mutually exclusive, it can also be written as this. The probabilities are equal, and then we can write it like this. So this is my equation 2. Putting this value in equation 1, we will get probability of A union B is equal to probability of A plus probability, and which is the required result for two non-mutually, which those two events that are not mutually exclusive. But if two events are mutually exclusive as shown in this Venn diagram, then A union B is equal to this. Since A and B are mutually exclusive, therefore A intersection B will be phi and probability will be 0. So putting this value in this equation. Next one is, if a card is selected from, what is the probability that the card is a club or face or both? So the sample space contains 52 elements. Let A be any event that the card selected is a club card, which is the first that the card is a club card. That is, Number of elements in set A is 13 and its probability is this one. So next one is the face or face card. Now B be the event that the card set is a face card. This one, face card. Now you can see this A intersection B. This is or both. That the card select is club or face card both. That is 3. We have got 3 face cards, so it will be like this. So now probability of intersection B is this one, and what we have to get? We have to get this A union B club or face, which means this whenever this OR comes, it means A union B. So A union B is this one, and the result is over here 22 by 52. And I remove this, I put it over here, then you'll see the result. Question for students. This one you will have to solve it by yourself. We are almost at the end of our lecture. You have to do it by yourself. And this is one more question. A pair of dice are thrown. Find a probability of getting 5 or 11. Solution: there are 36 sample points which have been already made. This sample space has been written. Now let A be an event that the sum is 5. So 5, this is 5. Sum these 4 items has got a sum of 5. So the probability is 4 by 36. Now the next B be the event that the sum is 11, and 11 is one is over here and other is this one. So the probability is 2 by 36. And A union B is probability of A plus probability of B, since nothing is common in these 2 events. You see, this is 1 event, this is 2, and if we go for A intersection B, we will get a null set. So nothing is common. So, and that's the end of today's lecture. Thank you very much.